Question 37. The following thermochemical equation represent the neutralization reaction between 25 cm³ of the nitric acid with 25 cm³ of potassium hydroxide solution. So the temperature of the mixture increased by 7 degrees Celsius, and this is the thermochemical equation that we get, given that the specific heat capacity of the solution is 4.2 joule per gram per degree Celsius, and the density of the solution will be 1 gram per cm³. So actually these two, okay, so the volume is 25 cm³, and over KOH is also 25 cm³. So actually we are going to calculate the molarity of the solution. So in order to calculate molarity, it is molarity equals to the number of mole divided by volume in decimeter cube. And we have another equation which we can use, which is delta H equals to mc theta divided by number of mole. So for this formula, since we are given the delta H together with mc theta, so it means that we can find the number of mole. So number of mole equals to mc theta divided by delta H. So mc theta for mass, how are we going to get the mass? Mass is actually the volume times the density. So in this case, 1 times volume is 50, because there are 2 solutions that are missing out. So the total volume will be 50 cm³. So times 1 equals to 50 gram. So 50 mc theta, C is the specific heat capacity, and theta is 7. Delta H, if you notice that this delta H is actually in the unit of kilojoule, kJ. So in over here, for the specific heat capacity, it is joule. So it means that we need to do some kind of conversion so that we can get the correct answer. So in order to convert kilojoule to joule, we need to multiply by 1000. So this is actually 57 times 3 times 0.3 times 1000, and then we will get the answer. So let's do some calculations on that. So it is 50 times 4.2 times 7. The answer is 1470, and then 57 times 0.3 times 1000 equal to 57300. So the answer would be 0.0257 mole. So if you can convert it to the fraction form, you also can write 49.1910 mole. But usually we use decimal. Yeah. So since we already get this number of mole over here, then we can calculate for the molarity already. But we need to calculate for both solutions. So for the respective solution, it is like this. Molarity equals to the number of mole, which is 0.0257 mole, and then volume in decimeter cube. So if we want to do some conversion, it is divided by 1000, because decimeter cube to cm³, we need to multiply 1000. So if you want to go backward, it is divided by 1000. So the answer would be 1.026 mole. So the answer is B. So the reason why we get 1.026 is actually because like we tag only for 4 significant figures for this mole. So if you use the fraction form, you can definitely get the same answer as like this. So it is because sometimes when we do for the calculation of number of mole, sometimes it has many decimals, so we only take the front 4 significant figures usually, and then we can calculate it. So the answer definitely will be slightly different, but just a very small difference for that. So let's continue with question 38. So this is a chemical equation that represents a reaction between the chlorine gas and the iron wood to produce the brown solid X. So the question is asking, what is the mass of X produced when 120 cm3 of chlorine gas reacted with the hot iron wood at room temperature? So given the relative atomic mass of each element involved and the molar volume of the gas at room temperature is 24 dm3 per mole. So for the transition metal, so actually iron is a type of transition metal. So it means that it can have more than one oxidation number. So in this case, we have two possible oxidation number for iron, which is Fe2 plus and Fe3 plus. So now we are going to look at this equation provided, which is 3Cl2 plus 2Fe forming 2X. So actually this is definitely the iron chloride. So let's say we have this Fe2 plus first. So let's see what is the chemical formula for this X. So usually we write Fe and then 2 plus. 2 plus is the charge, the oxidation number also for the iron. And then we know that chlorine is, for chloride ion, it is Cl negative. And then when we cross it, then copy down the Fe, the iron, and then copy down the opposite charge for chlorine, which is 1, and then we usually do not write out the 1. And then copy down the Cl again, copy down this 2 plus over Cl. This is what we say cross the charge. So this is FeCl2. So let's say if we put this FeCl2 to the X here, we need to check whether it is a balanced equation or not. So let's say we put this FeCl2 to here. Okay. Okay, we have 2 iron. Okay, for iron it is balanced. If for chlorine it is 3 times 2 equals to 6 at the left hand side, and then 2 plus 2 chlorine, which is 4. So 6 is not equal to 4. So this is not a balanced equation. So definitely we know that the answer would be Fe3 plus. But we also need to check it again. So let's say we do a cross again. So copy down the Fe3 plus. Now we substitute the 2 plus to the 3 plus, and then same chlorine. Then we cross it. So the charge for the chlorine now is 3. We need to copy down the opposite charge for the element to the chlorine. It always opposite. So when we put this X equals to 2 FeCl3, and then we need to check whether it is a balanced equation or not. So 3 times 2, 6. 2 times 3, 6. Okay, this is balanced for chlorine. And then we need to check for iron, which is 2 iron, and over here 2 times 1, 2 iron. So this is the balanced equation. So we want to find the mass. Sure, we need to know what is the number of mole, because we need to know, in order to calculate mass, the formula would be mass equals to number of mole times the molar mass. So given that we already have the volume and molar volume, we can calculate for the number of mole for the chlorine. So you just put the number inside, and then you will get 0.005. The things that I want to emphasize is that why we need to divide it by 1000 is because, do you notice that the unit for this 120 is cm cube, and for molar volume it is dm cube. So in order to convert the cm cube to dm cube, we need to divided by 1000. Next, we are going to get the number of mole for the iron 3 chloride. Because do you notice that this number of mole is actually for chloride but not FeCl3? So you will ask, teacher, if I don't know the number of mole for FeCl3, but I only know number of mole for Cl2, so how am I going to get the number of mole for FeCl3? So actually, you need to compare it, get the information from this balance equation. So the reason why balance equation in SPM is always very important, because sometimes you might need to get the hidden info behind the balance equation. So, okay, we know that the number of mole for Cl2 is 0.005, and from this balance equation, we know that the stoichiometric coefficient for Cl2 is 3. 3 to 2 FeCl3. So we write a comparison over here, which is the number of mole of chlorine equals to 3 over 2. 3 is because from the equation we get 3, and then from the equation we get 2. The stoichiometric coefficient for FeCl3 is 2, and then we input it, then we will get the number of mole for FeCl3 is 0.0033 mole. So now, by comparison, we already get the number of mole for FeCl3. So we put this number into here to the number of mole, and then we are going to calculate for the molar mass. So for molar mass, it is pretty easy. You just need to put the molar mass for FeCl3, which is 56, because 1 Fe only, 56, 1 Fe only, and then we have 3 chlorine, which is 35.5 times 3, and then do some calculations. The answer would be B. Question give a chemical equation that shows the complete combustion of butanol. So it is asking what is the mass of butanol that is required to produce 360 cm3 of carbon dioxide gas at room condition. So given that we have this information, which is the molar mass for the butanol is 74 gram per mole, and molar volume of gas, which is 24 dm3 per mole at room condition. So what is the mass? So mass is what we are going to find for this question, and this is the volume. So in order to find mass, we need to know what is the number of mole times molar mass. So for this formula, we already know for the molar mass of butanol is 74, but we don't know the number of mole. But the information given is volume, so we can find the number of mole equals to volume divided by molar volume. But we need to know that this volume of gas given is in the cm3 unit, but over here for the unit of molar volume, it is dm3. So we need to divide it by 1000, as what I mentioned in the previous question before. So let's calculate it. So the number of mole is 0.015 mole. So we can put this number into the number of mole over here, and then we calculate it. So when is the mass of the butanol produced? Oh, okay. Sorry, we shouldn't put this 0.015, because I just noticed that this 0.015 mole is the number of mole for the carbon dioxide gas. So the solving skill is just like the above. Like over here, we can put the number of mole of CO2 over number of mole of butanol, because this is what we want to know, which is C4H9OH. And then we need to refer to the question, which is in this balanced equation, the stoichiometric coefficient for carbon dioxide is 4, and then for the butanol is 1. So we usually do not write out the 1 for 1 mole of the substance. So we put over here 4 and 1. 4 is for the stoichiometric coefficient of CO2, so they must be balanced. Like over here you put the number of mole of CO2, you cannot put the stoichiometric coefficient of this C4H9OH, it is wrong. So as what we know already, this is 0.015, number of mole of CO2. And then number of mole of C4H9OH equals to 0.015 divided by 4. Then we need to calculate for it. So the answer would be 3.75 times 10 to the power of -3 mole. And then we put this number into here, into the formula, and then times with 74, we will get 0.2775 gram. So the answer is B, which is approximately 0.028 gram. For question 40, this is a diagram below shows two different reactions of lead-2 carbonate. What is the mass of the solid Z formed? Again, it is mass. We need to find the mass when the same mass of lead-2 carbonate is used. Okay. Okay, so this is a bit KBAT question. Okay, so let's look at this process, the reaction first. So lead-2, I hope you all know what is the formula for lead-2 carbonate. If you don't remember, so it is like this. So we know that lead is 2 positive, and then carbonate is 2 negative. And then we cross it, Pb2 CO3 2. Since both of it is actually 2, and then the equation would be like the chemical formula would be like PbCO3, because we can simplify the 2. So we know that PbCO3 plus HNO3. HNO3 is the chemical formula for the nitric acid. Yeah. So it will form the salt, which is PbNO3 2 plus CO2 plus H2O. Then we need to balance the equation. So we put 2 in front of the nitric acid, and let's see whether it is balanced or not. Okay, so 1 Pb, 1 Pb, okay. 2 NO3, over here also 2 NO3. And then C, 1C, 1C, okay. We have 3 plus 2 times 3, 9 oxygen. So over here also 3 times 2, 2 plus 2, 8 plus 1, so 9. And then we have 2H. So this is a balanced equation. So okay, so given this information, so actually the salt X is referring to here. This is the salt X. So the reaction between lead-2 carbonate and nitric acid will produce a salt and release carbon dioxide and water, which image the information provided in the question. So given the mass, given the molar mass over here, then we can calculate the number of mole of PbNO3 2, which is 16.55 divided by 207 plus 2 bracket 40 plus 16 times 3 equals to 48. So we can calculate the number of mole, which is 0.05 mole. Okay, since we get this number of mole already, okay, let's see another situation over here. So this is a lead 2 carbonate. So when we heat it, it will decompose. Heat will decompose the salt because the salt is not stable, therefore it decomposes. So this PbCO3 after the heating reaction will release PbO plus CO2. So let's see whether this equation is balanced or not. Okay, so Pb, okay, we have 3 oxygen here, over here also 3 oxygen, and then okay, 1C, so this is a balanced equation. Again, if you don't know how we get this solid Z, actually it requires you to have a little bit of understanding on the chapter which the heat reactions will decompose the salt. So Pb2 plus, together the oxygen is also 2 negative. So when we cross it, actually we need to write down the O. But since this, we need to write down the 2. But since these 2 can be simplified, so we will get PbO. Okay. Okay. When the same mass of, okay, so the question said same mass of the lead 2 mole. So we know that, okay, from this equation, we know that, okay, 1 mole of the PbCO3 is equivalent to 1 mole of the PbNO32. So we can deduce that this PbCO3, we are also using the same mole for that, which is 0.05 mole. So when we want to calculate it, then again we need to compare. We always need to compare and deduce. So for the second situation, 1 PbCO3 is also equivalent to 1 PbO according to the balance equation. So students, you must always remember to balance your equation, or else you cannot find the answer. So the mass of the solid Z, which is the PbO, equals to 0.05 mole times 207 plus 16. Okay, so let's see what is the answer. So the answer is 11.15 gram. Okay, so this is the answer. So actually, always for the calculations, we need to find the number of mole. Yeah. So this is the end of the question.